Okay, now we're going to look at the inverse tan function. Again, like the inverse sine and the inverse cosine. We're going to have to restrict the domain because, again, our sine function we know is cyclical. So it repeats, which means it's not going to pass the horizontal line test. So we're going to look at a portion of our sine graph. And we know that when we take the inverse of something, we've got it, and usually we rotate it just so, all right? Or we flip it. So with that being said, what we're going to look at, undo that. What we're going to look at is we're just going to look at a section from negative pi over 2 to pi over 2. And again, that's like our magic number with the arctangent, just like it is with the arcsine. So again, here's some math mumbo jumbo, but what's nice is we've got a nice little picture right here. And there's the portion of our curve that we're looking at, and that means that we've got the range is the interval of pi over 2 and negative pi over 2. So we've got the bottom, and then we've got the top. So next page, inverse tangent. We've got a bunch of more math mumbo jumbo. Basically, it's on the interval of negative pi over 2 to 2. Make sure that it can be written like this. All right, and again, more inverse tan properties. The inverse of tan and tan u equals u, because right here is if you've got the inverse of a function and the function, those are going to cancel, leaving just the variable or the value. And that's if and only if it's negative pi to 2 pi halves. So that's what you need to remember. The same rule is going to be the same if you do sine and cosine. If you have a function and then you take the inverse of function, it's going to cancel out. And that's pretty much what this is saying right here. Okay, the function cancels. And you are left with the value. But make sure that you stay within your interval. Okay, so evaluating the inverse tangent expression, it's going to be just the same as if you did with the sine and cosine. But the difference is you know that tangent's not found in the unit circle. So if you're looking at the inverse of tan to the negative 1, first of all, you know that you cannot use second or third quadrant. You are only looking at, so you're just looking at quadrants 1 and 4. So we're looking for when tangent is a positive 1. I know that a number divided by itself is going to be 1, but if I look down here in the fourth quadrant, that's going to give me a negative 1. Here, I've got a nice positive 1, so the inverse tangent of 1 is going to be pi over 4. Okay? And the next one, we've got tangent, the inverse of tangent of 136. That's going to be when we find our beautiful calculator. We go into our basic thing. I'm in radians, so I need to go ahead and change that to degrees. All right. And here I'm just going to hit shift tangent, and then I'm going to do 136 and get my answer. So it's going to be 89 and 58 hundredths. So I've got 87 and 58 hundredths degrees. Okay, so that's a basic arctangent operation. Now let's look at some more fun things. Exact values. Find the exact value of cosine times inverse of tangent pi over 2. Here's where we're going to draw our beautiful, beautiful triangle. We know we're not in quadrants 2 and 3, and we are positive, and I'm tangent. That means I am opposite over adjacent. So opposite, I am root 5. Adjacent, I am 2. So let's go ahead and find our hypotenuse, which means we've got 2 squared plus root 5 squared. That's going to be 4 plus 5 is 9, and root it. So that means my hypotenuse is going to be 3. Okay. So now that we've used the inverse of sine, root 5 over 2, to establish the triangle, we have solved and we found that the hypotenuse is 3. So basically now we know that cosine is going to be the adjacent over hypotenuse. Adjacent side is 2, and the hypotenuse is 3. So cosine with the inverse tangent of root 5 over 2 is 2/3. Okay, so basically we're just taking basic sine, cosine, tangent fun stuff, drawing the triangle, and finding the other values. So this goes back to the simple things we were doing before we did the super fun identities. All right, that concludes our arctangent little video. If you have any questions, come see me. Thank you.